I never want to pay electricity bills again. And today's video it's about that topic, and I will show you how to build a windmill to skip that task in your life. So when every month when your neighbor is going to pay the bills, you won't pay the bills ever. No, I'm slightly exaggerating here, but seriously, the video is about an idea about how to build it way cheaper with less effort, and I think it will be like, and I'm not exaggerating it, I really mean it. I think it's like 10 times better than 99% of the windmills that are out there, because most of them are made by engineers and they overcomplicate things. Not that I didn't finish architecture, so I'm not architect and kind of things, but I see it simple, because if you're taught by somebody like, hey, we need this, we need that, that's complicated. And I just, so the video is like to throw out the complicated parts and just keep like the simple parts. And the whole idea here is like when I started to build the thing, I was like, okay, do we really need this part? And I was sleeping on it like a day or two, and oh no, we can keep that part. It's too expensive or it's too labor intensive, and we throw it out, And after a while, you just throw it out everything, and maybe 1% of the effort and 1% of the price, or like the money you have to pay the materials will do like not all of the work but like 80% of the work. Let me show you how it works. So I'm not selling a cat in a hat, and I don't want to sell you anything. I want to show you exactly how to do it. Maybe not like from A to Z all of it, so it's not a tutorial, but I show you the big picture and you will be able to continue. Or if you're not an engineer, you will ask the neighbor's kids and they will help you. It's like really easy. It works if you want to build like a small one, and if you want to build like an industrial part. And the best part of it, it's like really simple to do it. You don't have to buy a lot of things for it, and it's like really easy to understand. So let me show you how it works and what's the difference. And I put like errors in it, and I will show you why not to do it like that way that I did it in the drawings. And what's the benefit of it, and what's the downside and upside of it, and how to do it like even better when I did it compared to my renders. So in the first video, I will want to show you like a complicated version, because if I show you like the version that's like the end result, you won't really understand like, oh, why it's there. I want to show you the process, because if you really get why there are elements thrown out, basically, that we don't need it, and you understand the logic, you will start to think about that even in your own life, like with other projects as well. So it's not that design, it's not the final design, it will be even cheaper than this, for example. So look, let's take for one element at the moment. So look at the metal sheets, the bended metal sheets there. And I really like it because those metal sheets, I think it's like 0.3 or like 0.4 millimeters. So it's like really, really thin, And the good part in it, you don't need like heavy machinery, you don't need technology, you don't need a factory. You just need like a five grader kid that can bend like a metal sheet, like with 2 fingers, like 4 fingers. And that's it. So I like it. See the logic. You don't have to overcomplicate it. You don't have to have like really long things. It doesn't have to be like 20 meters long, like a spaceship size. No, it should be small, and it should be cheap, and it should be like bended like really easily. Basically like the form itself bends in that way like naturally. So we don't have to fight it. We don't have to buy the material from the shop that we will start to tool and mill and like a lot of complicated things. Now you just bend it, you put like 2 cables there, it's ready. That's it. That's all, folks. Yeah. And the other parts, I will show you like what are the flaws and what are the weaknesses in design. So let's stick with the overcomplicated version, Let's stick with that for first. So the homemade wind turbine is like really easy to do. You don't have to use a lot of materials. If you look at the picture, you can see from start that the structure itself, so okay, you have the blades that are occupying a lot of space. Like that's obvious because you have to grab the wind somehow, So the more wind you grab, the more power you will have. Like it's basic logic. It might be like another version as well, but I'm just thinking about it in the mechanics, But if we don't think about the blades, because okay, we pay money for the blades because the blades grab the wind. That makes sense for me, you know. But the other part, that the blade, we shouldn't pay money for it because it's not grabbing the wind, it's just like keeping the blades in a place and rotating. See my logic? I'm like the person who doesn't want to pay like $1 even when it's like Christmas party. So yeah, so here, if you can tell, there are no big elements. Like everything is missing because if you look there visually, you don't see like a slab, you don't see like big things there. Everything is missing because I was like really short. And how can you do it? You can do it with the cables because if you think about, let's say that's the windmill, you know, it's here, it's standing. The wind comes and the wind wants to push it down. And you have two options. Like one, you do that, like you make this one like really strong, and it costs you like millions and millions of dollars or like hundreds of thousands of dollars to grab the wind, and it's huge, you know, like everything is big one. Or you make a lot of small ones. But with the small ones, it's the same problem because the higher you get, the more wind you grab, the more power it has. And if you put like cables, like a lot of cables here, that means it will be like really easy. It will be like a counterweight, you know, because we have that in mechanics. It's like M, the momentum equals the force or the length. So basically, the longer you go up, the more force you will have. However, if you have a cable here, it's like really easy to counterfight the problem, you know. And if you have more, and you're thinking about the matrix, if you're looking from above, you're not having like one windmill like here, like a pond, you know, or like two or three in a row. You're having like 10 or 10. That means you're having a matrix, you know. And if you start to put cables there, that means the wind will have to pass because eventually the wind will pass in a way or not, you know. And if you have like a lot of like really short tiny cables, you will use maybe hundreds or like thousands of the material. Think about like an airplane, you know. If you want to put an airplane on a bridge, let's say you have a bridge here, and you put an airplane on a bridge, you have to spend like millions of dollars on the bridge that supports the airplane. However, if you put like a tiny cable, you can just like drag the airplane wherever you want because it's like a $1 cable, you know. But with the bridge that supports the whole airplane, you have to spend millions of dollars. So it's the same thing. You put it on cables. I don't know why they are not putting on cables, but you have to do so. So that's one of the big ideas. And the second one, the horizontal lines, and that's one of the errors that I told you, like here, because let's say you have a windmill here, you have another windmill here, and you have like a lot, maybe like hundreds, it doesn't matter. In between, at first, I put like a metal beam, but you don't want that. Why? Because the metal beam, it's like really expensive as well. You can put like X's, like cables, you know, because if you have like two metals here that support the rotating blades here, let's say those are rotating, you can skip that. You have to put like a metal here. But in between, you don't need to put a metal because it's really expensive. You can put like two X's, like one X here, you know, and you put one X below. And therefore, they can move. It will be stuck, you know, it will be stuck in position. And if you have like 1, 2, 3, 4, 5, 6, 7 in a row, and in another row as well, you know, like if you're watching from above, it will be like really extremely powerful, you know. It will be like a wire mesh, and it will be like maybe using a thousands of the material needed, you know, and it will be extremely efficient. And because it's prefabricated, you will be able to build like maybe if you have a team there, you'll be able to build like hundreds in a day, like literally, you know. And even with a screwdriver, you will be able to put it up. And even the foundation will be like really cheap. Why? Because if you are not having the weight, you know, in one position, and all of the force and all of the momentum, like I told you, like the momentum equals the force or the length, you know, you don't have one foundation. You will have like hundreds of small foundations. That means you won't even need to make a foundation because you will make like an anchor. It's like just imagine like a cable, and you don't need a concrete to put in a cable. You're just making like a screw, and you make like a hole in the ground. It's like a screw, something like that. and when you make a hole in the ground itself will hold the cable. So all the expenses and all of the things will be like really easy. And even so, if one thinks, let's say, it damages, it will be like really easy to like replace it, because you don't have one, you have like hundreds. And not in a way, oh now I have to repair hundreds. No, it will be easy to repair it. And I had like two errors here. Like one, if you see there are like tiny cables that are in the metal sheet. So let's say that's the metal sheet that's like wrapped, and you have here a cable. You don't put it like parallel, you like put X's, because that way the metal can bend, like hold it with the X's, because that's like the force that will make it like be really rigid. And the other one, between the windmills that I told you, it won't be like a solid rigid like metal bar, it will be like X's as well, because it's like way easier and cheaper to do so. And because you don't have welding, you don't need painting, you don't need like hammerite, you don't need nothing. You just put there like the metal cables, that's it. Like you screw it in, you like tension them, pop, you like in 2 minutes you're ready. You're on the next job. So that's it, that's all folks. And you can make it like in two ways. So you can put a motor like on every other like windmill, or you can put like one, and that's easier as well, because if you think about it, the wind it's moving in the same constant speed, let's say. And mostly I'm proposing, let's say, think about the bicycle. Probably you've seen bicycles that are made for like 2 or 3 persons, and 2 persons are on the same bike. So why not? Why we need to put a motor on every windmill? Just put one motor, you make like a elastic band or something there. I'm not sure, but you can like pair like 2, 3, 5, maybe even 10 windmills with one. Because if one is rotating, the second is rotating, and they rotate like one, I don't know, like rubber band. I'm just like saying it for fun, like one big rubber band, and you have like one motor. You have to make the calculations what's cheaper and like what's better. Or you make like small motors, because the small motors are like really cheap, but you have more, and the bigger motors are more expensive and they might be more energy efficient. However, if something is bad, then you have to replace the whole motor. But what I like in design, that it really grabs the wind. And probably that's why it will work out really well in like low winds. You don't have to have like a really powerful wind. It will go. So in the fourth video, you can see it even better that I let the like really let's say expensive like metals, that are like in that direction. And we don't need that. We just throw them out. And the only thing that we have to be aware that if the windmill is here, let's say that's the height of the windmill, and if you have the expensive metal bar, means you can go like maybe like a few inches, like 10 centimeters above the windmill. However, if you put the X's, you put the X instead, you have to go higher, like a meter or 2 meters, depends of the engineering, and an engineer should calculate. You never do that alone, so like trust me. I like do-it-yourself project and like finished architecture, but even if you're like doing do-it-yourself projects, and like I'm really advocate of that, but things like that, you never do it alone. Please pay a local person that's like certified to do it, because if it's somebody get hurt, that you'll get in trouble, and you don't want that. So even if you do it like you say, yeah, it's just like my farm and nobody comes here. No, please pay an engineer and at least the calculations for that, because you never know. They know about the wind, they know what's the force, they know everything, and it will be cheaper for you to do so. Even if you like pay somebody on Fiverr.com. I'm just kidding here, but please pay somebody in your local area that certifies to do so. Probably they won't like it, but find somebody who will be interested to take your money, because somebody will take your money and will make proper calculation. And now we're at the third video, and sure, if you say, oh, I can't buy that metal sheet because you can buy that. No, you can buy it at Walmart, at like the nearest like store, and I think they bought them together. I'm not sure about the word in English, but you just use like screws, you make like a hole and you bore them together. It's a machine. So basically you have like two plates. It's like put an overlap, like a few centimeters, like a few inches, and afterwards you have like a machine that you put on it and like tick, it makes like a hole in it, something like that. And it's like really easy and like really cheap to do so, and you can make it in like a few seconds, it's like, and that's it. And even if you're saying like, yeah, but it won't work, yeah, but if it will produce you like electricity for free for like a few years, and you will pay like maybe hundred of the price, like shorter. Yeah, probably it won't last like maybe 20 or 30 years, but who cares, because it will make you like for the pennies electricity for maybe 5, 10 years, like who cares what happens after it. And I'm not exaggerating here, because what do you want? You have a problem, like let's say you don't want to pay electricity, and with pennies you can solve it for years. And in 5 years you can solve it again, because if you think about it, you have to put, in other versions, you have to put a lot of money in the problem, and you have to wait a lot of time to get the money back. Here, you won't put a lot of money in it, and you will get the money back almost on the instant, maybe in a few months. And afterwards, it produces you energy. You don't have to wait like 10 years, I don't know, like 5 years, 10 years, or think about it. Oh, let's make a proper calculation. If in 6, 7 years, no, it's not 6, 7 years. It's like seconds. I'm exaggerating here, but here the wind, it will produce you like a lot of power on the spot. And because you didn't invest in it, the return of investment is like really good. Keep it simple. The only thing that I'm always repeating, so put the X everywhere with the cables. Don't make like the straight, like heavy metal things, because it's expensive. And you have to weld, you have to put the hammerite in it, you have to put like the expensive painting, or like the inox, or like the zinc. It's a lot of money. Don't overcomplicate yourself. Cheap cables, pack, you did it. You go one afternoon, you make like 100 pieces of windmills. Yeah, surely I'm again exaggerating here, but we don't need to overcomplicate our lives. Not to spend like years on one project when we can make like a lot of projects. And the fifth video, again and again and again. Keep it simple, guys. Don't put like the metal bars in it. If you make everything, like put the question like 10 times. Do we really need that metal? Do we really need to weld? Because if you think, oh yeah, I'm welding it there, yeah, but afterwards you have to load. So it's like an avalanche. If you start to make one thing, it will have a consequence to use a lot of other things. Because look, here with the cables, what you need a screwdriver, like how much is that? Like $300 for, let's say, I'm exaggerating here, you make a hole in it. What do you need there? You don't even need, because if you just think about like the logic, and I'm like, surely I'm overcomplicating it, but if you have like a film, or you have to make a windmill, and the engineer, like the highly paid engineer, like the neighbor's kid, it's making you a drawing with it, and afterwards you go to the mayor office and they say, hey, yeah, I want to build that. And they will say, okay, you have to build it, there are like the plans, but you need a company to do it for you, and the company have to have like all kind of like ISO certificates, like, oh, they can weld, they have like a certified person to do so, like the welding, they have like a certified person to put the zinc or like the paint on it, and you have like a lot of things. This is like a snowball effect. But when you have like a piece of metal, like a metal bar or like a metal cable, what do you need? It's like the engineer told you, you need like an 8mm, 10mm, 1-inch metal cable with that strength. And you buy it. That's all. What certificates, what complicated film, who, So if you have that, even like I'm again exaggerating here, even a 5th grader can do it, because the 5th grader have all of the certificates, because you need to drill a hole, and what certificates you need to make a hole. And again, you're laughing at me and saying, yeah, you're overcomplicating it because I don't want to pay something. No, because if you think about, even if you're in the United States, here in Europe, I don't want to be mean, but here in Europe, somebody who's welding or somebody doing the job, it's not getting like a 5,000-10,000, I don't know how many thousand euro salary, But in the United States or maybe Australia or like in other countries, you have to pay that persons because they have that certificates, you know. Here we have as well, but we don't have to pay that much amount of money. However, even so, it's like expensive because they have the certificate, you have to pay them. However, if you drill a hole in one piece of metal that already has the zinc coating or like the paint on it, you know, by the factory, you buy it. You buy it from the first hand on the factory, you put a hole in it, you put a screw in it that's already certified, the screw, and you put on the screw a cable. See? So a lot of like, it's like buying something from the factory and you don't have the layerings, you know, you don't have, oh, I bought something from a company that's making something for another company that's adding something to it and the secretary of that company and no, you buy from the factory and the neighbor's kid assembles it, the fifth grader neighbor's kid, because the fifth grader neighbor's kid has all of the certificates to do so. Again, I'm overcomplicating it to get to the point. See the idea? So don't cut the video. I'm not saying like, oh, I want the neighbor's kid to assemble it. It's a bad idea. I'm just telling you don't need to have that many certificates, and therefore in your town it won't be like two or one team that can do it, or you don't have to pay a team from like 2,000 kilometers to go there and to assemble it, because in your town you will have like hundreds of companies that are certified to put a cable in a hole and the screw that's already certified by the factory. See the logic? So if you think about building something, don't just think about like the materials bought. You need to think about the bureaucracy of the things, let's say, or like the paperwork of it. And if you can skip the paperwork in a legal way and everybody's happy about it, you know, then it's okay and you should totally do it. Because one thing that we saved a lot, like hundreds of thousands of dollars, even millions of dollars you can save building this way, you know, on the materials by themselves, but leaving like the paperwork out, that's even more easier. See the logic? And it's cheaper and it's extremely fast because you have the idea, you have the plans, the plans are there, you just pay the nearest engineer that's like a certified engineer, it will make you the plans, like how to do so, you know, and you can build it in days. So let's say there are like a wider spectrum of engineers that can do that for you. And therefore, the whole thing, it will be like really, really cheap. So that was today's video, and hope I will see you in the next video and subscribe. So bye bye.